In this video we're going to be discussing the dot product, which is also called the inner product. And you can see here that the dot product is multiplying two vectors together with a dot in the middle, again also called the inner product. So if we had vector A and B, we would just take the x components, we can write that down here, of each one, and we would multiply those together, then add the y components multiplied together, and then add those up. And that's defined as the dot product. There is another type of product that we'll discuss in a later video. This is also different than scalar multiplication, where we would have a number outside and multiply that by a vector. Here we're actually multiplying these two vectors together in a way that's called the dot product. We're going to draw a couple vectors here on the little graph on the left hand side. So the first one is going to be -4 and then 2. And we'll make that vector A. And then we'll make another vector B, and that will be at 3 and 6. So that might be out here, and then maybe this is 6 right here. It's pretty close. And what we're going to do is we're going to take the dot product of these two, and there's a very special thing that we know happens when the dot product is 0. So I'll put a little asterisk here, put when or if, when the dot product, oops, let me spell correctly here, dot product is 0, the vectors are perpendicular. So kind of a special thing happens there when if you take the dot product and it's 0, then that means that those vectors are perpendicular. So let's see if that's the case with these two. I'll move this up just a tad, and we're going to write that like this: -4, 2, dot product, and then 3, 6. So to find that, we're going to multiply the x components of each one together, then add the multiplication of the y components. By the way, if you had a z or any further component, then you would just add the multiple of each one of those components together too. So you can see that the dot product here is -12 plus 12, which is 0. So if this is the case, then we can say that the two vectors are perpendicular. So we could say that A is perpendicular to B. So the actual dot product itself is this value here. If it's 0, A is perpendicular to B. If it's not 0, then A is not perpendicular to B.